Okay, question 3. Skulls of 2 mammals. Identify the mode of nutrition for each animal. Well, they are both heterotrophs, but that wouldn't be very good. It probably wants the difference between them. So you've got herbivore and carnivore. So herbivore, carnivore. And we need an adaptation. So there's millions of things you can say here. You could, for the herbivore, you could say these incisors only on the lower, and they would press against a horny pad for grasping grass. You could talk about these molars interlocking for grinding grass material, and enamel ridges and so on. You could talk about this gap here, the diastema. So any of those will do. Let's talk about, I like to talk about the actual teeth. It says dentition, so I'm going to say interlocking molars. Molars with enamel ridges and for grinding plant material. That's the kind of most obvious thing to me. And then we've got carnivore. We could talk about these incisors, top and bottom, for grabbing hold of prey or stripping flesh from bone. Talk about these really, and this one's beautiful, large canines that are curved for piercing flesh, keeping hold of the prey, killing the prey possibly. And then you could talk about the teeth further back, carnassials, sort of have crushing bones, shearing flesh, that sort of thing. I'm going to talk about these canines. So I'm going to say large curved canines, large curved canines for seizing or killing prey, seizing and killing prey. Then we've got a table showing the gut of P and Q, so they're guts, and P has got a very large stomach, so things like sheep's, cows, and you've got kind of dogs and wolves and things like that for carnivores. So about the rumen and so on. And in our dog, for example, smaller than the cow stomach, but still quite big compared to the rest of its system. Small intestine, caecum and colon. So the relative length of the gut, let's actually get down. So we've got medium there and very short. And it's to do with what it's eating. So the gut of the herbivore is long because it's hard to get energy from cellulose. Whereas carnivore, very short, as it mainly eats protein, and that's quite easy to break down protein. So for 1 mark we should be able to get that. So short in carnivore as protein, easy to digest, compared with cellulose. Or you could go the other way around, medium in the herbivore, as cellulose is harder to digest than protein. Describe how the stomach of P is adapted to its diet. So P is our herbivore, our ruminant, and so we're going to talk about digesting cellulose with cellulase produced by bacteria, chewing the good, regurgitating, a sneaky little mark to do with water reabsorption, and mentioning some structures, for example rumen. So let's start off with we need these bacteria. So the stomach of P contains bacteria. Contains bacteria that produce cellulase. So they're the ones that are actually going to digest this cellulose. And we're going to get regurgitation of the cud. So allows it to be chewed and chewed again, to try and break it down. We're going to mention a rumen, and that's the kind of first chamber with the bacteria in. So contains the bacteria. So these aren't really complicated points, and we can have this point about the water. So water can get reabsorbed in this stomach. So water can be reabsorbed in the stomach. In this kind of regurgitation and chewing again. And we could possibly mention any other kind of relevant points about absorption of fatty acids or anything else that you know about that. But there's 4 for you. 3 of them straightforward, 1 of them less so. It's just why Q has got the large stomach, so the carnivore. So why has it got large compared to the rest of the volume of the gut? And that is because carnivores, dogs, wolves, they'll probably only kill every now and again, but they need to eat a lot all at once until next time they can eat. So they need a large stomach to fit that meat in. So carnivores only kill periodically. So use stomach to store meat. And another possible reason is, well, if they're eating meat and their meat's protein, well, that's where they're digesting most meat, the protein in the stomach, as you know. So you could say, and protein is digested in the stomach. What evidence is there in the table to suggest that P is more able to absorb water than Q? So, what do we know? We got stomach, so that's got mechanical and chemical digestion, small intestine digestion and absorption, caecum, quite a lot of bacteria usually, and colon, that's water absorption. And so P will be able to absorb more water than Q because it's got a longer colon. And it's really just remembering what the colon is for. So P has a longer colon. Or you could say large intestine there. And part C, name the layers. So submucosa and mucosa. So it's just remembering your diagram. That's part 3 actually. How does this arrangement of fibres into muscle layers? So there's the muscle layers there. So you got longitudinal, I'll explain what these are. So longitudinal and circular. So circular kind of squeeze things that way. There's longitudinal, kind of squeeze it along their length, and that allows peristalsis to happen. So longitudinal fibres and circular fibres, and that allows peristalsis to take place, or shoving. So they'll contract to squeeze the food, and then the gut can move longitudinally or lengthways and squeeze again and keep moving food through.